Assalamualaikum. Today we are going to present about volumetric analysis in determination of zinc pyrithione in shampoo. We are from group FYS 120415. Before we start, let me introduce myself first. My name is Putri Sabrina and my fellow group member is Hani Arisa, Nur Damia Usna, Nur Najjar Nafiza and Nur Nabiha.
Before I dive into the compound we're studying, I'd like to start with a quick explanation of volumetric analysis, which is a key concept in analytical chemistry. Volumetric analysis is a type of quantitative chemical analysis where we determine the amount of a substance by reacting it with a known volume of a reagent. In simple terms, we add a titrant, something we already know the concentration of, until it completely reacts with the analyte, which is the substance we want to measure. The volume of titrant used allow us to calculate the concentration of the analyte. In this study, we're measuring how much zinc PT is in a shampoo sample by using two types of volumetric methods, complexometric and potentiometric titration. Now let's talk about the compound being measured, zinc pyrithione or zinc PT. Zinc PT is a metal complex that combines zinc with a molecule called pyrithione. It has antimicrobial, antifungal, and cytostatic properties. What that means is it helps kill harmful microbes like Malassezia fungus, which is the main cause of dandruff, and it also slows down the overproduction of skin cells on the scalp. Because of this, zinc PT is widely used in anti-dandruff shampoos and has been a common ingredient since the 1960s. So here's the most important question. Why do we need to measure zinc PT accurately? Just like medicine, the dose matters. Too little zinc PT in a shampoo and it won't treat dandruff effectively. Too much and it might cause skin irritation or even go against FDA regulation. For example, rinse-off products can contain up to 2.5% zinc PT, but leave-on products can only have 0.25%. So, accurate measurement is really important, not just for product quality, but also for consumer safety and regulatory compliance. And as we'll see in this study, volumetric analysis using titration offers a simple and cost-effective way to do just that.
I will be talking about the methodology on how the experiment was done. In this section, we will explain how the research measured the amount of zinc pyrithione in shampoo using two types of titration method, which is complexometric and potentiometric titration. We will look at the reagents and instrument used, how the sample was prepared, the titration step, and how the endpoint was detected in each method. Continue to instrument and reagent used. This table shows the main difference between the two methods. The complexometric titration uses EDTA as the titrant and a color indicator called Eviochrome black tea. Each time manual using a burette and flask. On the other hand, the potentiometric method uses iodine as the titrant and doesn't need a color indicator. It relies on a platinum electrode to measure voltage changes automatically. Thus, for sample preparation and titration procedure, first for every step is they dissolve the shampoo in ethanol, filter it, and then dilute it in solution. In the complexometric method, they added an ammonia buffer and the color indicator Eviochrome black tea. Then, they titrated it with EDTA until the solution turned blue, which marked the endpoint. And in the potentiometric method, they added glacial acetic acid and used an automatic titrator to add iodine. The platinum electrode monitor voltage changes to detect when the reaction was complete. Lastly, endpoint detection, color versus voltage. The key difference between the two methods is how they detect the endpoint of the titration. In complexometric titration, the indicator changes color from violet to blue when all the zinc has reacted. And in the potentiometric titration, there's no color change. Instead, the electrode detects a sharp voltage spike, which is recorded automatically and marks the endpoint.
Now, let's move to the part of the validation of analytical method. Precision refers to how consistent the results are when the same method is repeated under the same conditions. In this study, precision was evaluated in three ways, which are: first, System repeatability, where 3 standard zinc PT solution at concentration of 0.2%, 0.8% and 1.4% were tested. Second, method repeatability, where the same shampoo sample were analyzed multiple times using the same method. And lastly, intermediate precision, which was tested by 2 different analyses on different days and in 2 separate laboratories. All the results were expressed as relative standard deviation or RSD percent. A low RSD value means the method gives consistent results and is considered precise. Next, accuracy shows how close the test result is to the true or actual value. It was tested using the same 3 standard solutions, which are 0.2%, 0.8% and 1.4% of zinc PT. Accuracy was expressed as percent recovery, which shows how much of the known amount of recovery during the analysis. Again, RSD percent was also calculated to confirm reliability. High percent recovery and low RSD value prove that the method is accurate. To conclude, this analytical method is proven to be precise because it gives consistent results and accurate because the results are close to the true values. Therefore, this method is valid and reliable for analyzing zinc PT in shampoo.
Precision refers to the consistency of repeated measurements under the same conditions. It is commonly expressed using the relative standard deviation or RSD. In our study, the RSD values for repeatability, reproducibility, and intermediate precision were all found to be below 1.0% for both potentiometric and complexometric titration methods. These values fall well under the 5% acceptable limit recommended by the Association of Official Analytical Chemists, AOAC. This confirms that both methods are highly precise and produce reliable, reproducible results, which is crucial for ensuring the accuracy of zinc pyrithione quantification in shampoo. Next, we move to accuracy. Accuracy refers to how close a measured value is to the true or accepted value. In this study, accuracy was evaluated through percentage recovery. The average recovery for both titration methods was within the acceptable range of 95 to 105% as recommended for volumetric analysis. As shown in the results, complexometric titration achieved a recovery of 99.89%. Potentiometric titration showed a recovery of 99.96%. To statistically confirm these results, a t-test was performed. The t-values obtained were 0.44 for complexometric titration and 0.14 for potentiometric titration. Both values are lower than critical t-value, indicating no significant difference from the ideal 100% recovery. Therefore, we can conclude that both methods are accurate and reliable for determining the active ingredient, zinc pyrithione in shampoo. Let's look at the results obtained. This table summarizes the precision and accuracy results for both complexometric and potentiometric titration methods in determining zinc pyrithione in shampoo. Precision was assessed through several parameters. First, we have intermediate precision, reproducibility, system repeatability, and method repeatability, all expressed as relative standard deviation or RSD. For complexometric titration, RSD percent values range from 0.69% to 0.84%, while for potentiometric titration, they were even lower, between 0.18% and 0.40%. All values are well below the AOAC's acceptable limit of 5%, indicating excellent precision for both methods. Sample repeatability across 3 replicates also showed low SD percent values, where the highest being only 0.70% for complexometric and 0.36% for potentiometric titration. For accuracy, we analyzed percentage recovery. Complexometric titration gave 99.89% recovery, and potentiometric titration achieved 99.96% recovery. These values fall within the acceptable range of 95 to 105% for volumetric methods. In terms of accuracy RST, complexometric had 1.06%, while potentiometric showed 0.98%, both still within the acceptable limit. Thus, both methods demonstrate high precision and accuracy, making them suitable for determining zinc pyrithione content in shampoo samples.
Based on our research paper, 2 simple yet practical methods were successfully validated for quantitative determination of zinc PT in cosmetic products. The method followed USP and ICH guidelines and demonstrated strong specificity, precision, and linearity within the tested concentration range. The sensitivity of both methods was found to be sufficient for routine analysis, particularly in evaluating zinc PT content in shampoo products. This method complies with FDA concentration limits and do not require complex sample preparation, making them suitable for efficient quality assurance in cosmetic industry and ensuring consumer well-being. Among the 2 methods studied, potentiometric titration emerged as the most suitable technique. Based on our experimental finding, this method demonstrated superior sensitivity and accuracy with an LOD of 0.0013% and an OQ of 0.038%, outperforming the complexometric method. Additionally, it achieved excellent linearity with correction coefficient 1, a recovery rate exceeding 99.9% with RSD values below 0.4%. The robustness of this method was also evident as it tolerated small variation in sample weight, HCl volume, and stirring condition, ensuring reproducible results across different lab settings. Our research further highlights the practical application of this method in real-world industry settings. They can be applied for quality control of zinc PT-based shampoo, ensuring accurate dosing for consumer safety and full compliance with FDA regulation. We specify zinc PT content limit between 0.3% and 2.5% for range of product. For manufacturers, these methods are highly advantageous due to simplicity, requiring no complex sample preparation and fast turnaround times. Furthermore, they offer cost-effective alternatives to more advanced instrumentation like UV-Vis, HPLC, or atomic spectroscopy. While our study provides valuable insights, it is not without limitation. One limitation is that both methods were validated under controlled laboratory conditions. We may not fully reflect the variability in real-world manufacturing environment. Additionally, the methods were optimized for rate-of shampoo product and may require further adjustment for other cosmetic formulation. For future research, we recommend expanding the method validation to include wider variety of zinc PT containing products such as leave-on treatment or conditioner. Further investigation could also explore method automation or integration with portable device to support rapid on-site testing. This will enhance overall efficiency and broaden the industrial applicability of the technique.
And this is our reference.